Okay, so in the previous video we looked at scalar multiplication, so that was multiplication of a matrix by a number. What we want to look at today is how we multiply together two matrices, and this is not a very intuitive process. It is, however, a process that with practice will become second nature, but it is something you need to see, and I need to be able to demonstrate in order for you to be able to do it, but it is something that with practice you'll be able to do. I want to also be clear about the fact that whilst you have a CAS in Further Maths and your CAS can do the matrix multiplication for you, it is really important that you understand how to do the multiplication by hand, because it's fundamental to understanding so many of the questions, particularly when they're in context, and how would you multiply together two matrices to get it to produce what you want it to. So understanding how the numbers combine together in the process of multiplication of matrices is really, really important. You can't avoid this. There is absolutely no point in you doing this whole exercise just by typing them all into your calculator. You really must practice this process, okay? So as I said, it's not a really obvious process, but with practice, honestly, you won't even think about it. So one of the key things is that we can't just multiply any old pair of matrices. In the same way that we could only add or subtract if the matrices were of the same dimension. Now with multiplication, we don't need them to be the same dimension. We need a particular combination of things to be true. And that is the number of columns in the first matrix must be equal to the number of rows in the second matrix. Okay, so if we think about when we write down the order of a matrix, remember order of matrix is rows by columns, okay? So we need the number of columns in the first matrix, so the second number in the first order to be equal to the first number in the second order. Now that's a very confusing statement. So if, for example, let's have a look at this example. We've got matrix A, which has order or size or dimension of 2 by 2, and matrix B, which has order, size or dimension of 2 by 5. We need the number of columns in the first matrix, which is this number, to be the same as the number of rows in the second matrix, which is this number. Okay, so it is possible to do that multiplication because these two numbers are the same. So is AB defined, meaning A times B defined? Yes, we can do that multiplication. Now then the fourth column here asks us to give the order of AB. So when we do that multiplication, how big will it be? And interestingly, the size that we'll get is going to be that. It's going to be 2 by 5. Okay, so it is these two numbers in the middle that allow us to do the multiplication if they're the same, and then the order that we'll end up with will be the two numbers on the outside. Okay, so in the second example here, 2 by 5 times 5 by 2. 5 and 2 are not the same, so we won't be able to do this multiplication at all, and so therefore the order of AB is irrelevant. In part C, 3 columns in A and 3 rows in B will enable us to do the multiplication, and the matrix that we get will be 1 by 7. In part D, 2 columns in matrix A, 2 rows in matrix B, so yes, we can do that multiplication, and the order of the matrix that we end up with will be 5 by 3. Part E, a 1 by 4 matrix times a 4 by 1 matrix, 4 columns in this matrix, 4 rows in this matrix, so yes, we can do that multiplication, and what we'll end up with will be a 1 by 1 matrix, so it'll just be a single number. Part F, we have an M by N matrix multiplied by an N by P matrix. So matrix A has N columns and matrix B has N rows. So we can do that multiplication, and what we'll end up with will be of order M by P. Okay, so the other important note is that with matrix multiplication, it's not commutative. So number multiplication is commutative in that 2 times 3 is the same as 3 times 2. It doesn't matter which order you do it in, you get the same result. In matrix multiplication, that's not true. Sometimes you can't actually do the multiplication in both directions, but even if you can do the multiplication in both directions, in most cases it won't give you the same result. there are a couple of small exceptions to that, and we'll talk about those later on. So say, for example, if you think about this, if you take one of these examples we've just looked at up here, for example, you know, this one here, A times B is possible, but if we were to do B times A, we'd be trying to do a 3 by 7 matrix multiplying by a 1 by 3 matrix. And the fact that those two numbers are different would mean it's not possible. So A times B exists, and it gives us a 1 by 7 matrix, and we'll be able to work it out. B times A doesn't even exist. Okay, so it's a whole different thing, and you'll see through the process of calculating the multiplications why you get something very different, and why it's not possible to do if the orders don't match up properly. Okay, so to find the product of two matrices, each row in the first matrix must multiply, and I use that word multiply very loosely, each column in the second matrix. So rows times columns. The rows of the first matrix must multiply the columns of the second matrix. Now, as I said, I use that word multiply very loosely. We need to talk about what that means. As I said, it really needs to be demonstrated rather than explained. Okay, so AB, let's write out our matrices. AB, A times B, is 11 minus 5, just going to make it a bit smaller so I've got some space. 11 minus 5, 2 minus 3. I'm going to multiply that by -1, 6, 9, -3. Okay, this is a 2 by 2 matrix, this is a 2 by 2 matrix. It's possible to multiply them because of that, and what we're going to end up with will also be a 2 by 2 matrix. I'm going to give myself plenty of room here so I can write out what's happening. Okay, so each row in the first matrix must multiply each column in the second matrix. Okay, let's do it one at a time. So we're going to have first row is going to multiply first column. Okay. Now, the answer that we get when we do that, and I'll talk about what I mean by multiply, when we multiply the first row by the first column, that's going to go in row 1, column 1 in our answer. So top row by left column is going to end up in the top left. When I do the top row by the right column, that will go in the top right. When I do the bottom row by the left column, that'll go in the bottom left, and when I do the bottom row times the right column, that'll go in the bottom right. Okay. Now, when I say multiply, what I sort of imagine in my head is this row flipping around here so that it's 11 and -5. Okay, and then you're going to multiply, and add those together. So you're going to do, what it is 11 times -1 plus -5 times 9. That's what goes in the top right. Okay, and so that would be 11 times -1 is -11, plus -5 times 9 is -45, -11 plus -45 is -56. Again, if you need your CAS to help you out with the number work, that's fine. -11 times -1 plus, 11 times -1 plus -5 times 9, -56. Okay. Alright, now I've made a bit of a mess in here. Let's see if I can erase that without completely destroying everything. Okay, that was a -1. Okay, so then top right, we're going to do top row times right column. And again, I kind of imagine this row spinning around here. There's 11 here and there's -5 here. We're going to do 11 times 6 plus -5 times -3. 11 times 6 is 66. -5 times -3 is 15. So 66 plus 15 is 81. Okay. Now let's see if we can get rid of that out of there without deleting the whole matrix. Okay. Bottom row times left column is going to give me the bottom left in my matrix. And again, I imagine flipping the row around. So it's always flipping it in this direction. Okay. That's what you need to see happening to your row. So your row becomes 2, -3, and it goes next to the column that you're trying to multiply. You're going to multiply those together, and then you're going to add. Okay. So we're doing 2 times -1 plus -3 times 5. -3 times 9. So 2 times negative 1 is negative 2, negative 3 times 9 is negative 27, negative 2 plus negative 27 is negative 29. Okay? And then our final multiplication is going to be the bottom row times the right column. Bottom row times the right column. So we're going to, in that case, get 2 times 6 plus negative 3 times 3. Okay, so 2 times 6 is 12, negative 3 plus 3 is negative 9, 12 plus negative 9 is 3. And that's our answer. Okay, so row times column. Every row multiplying by every column will give us the answer that we need. Okay, and that multiply, essentially you're imagining spinning the row around in that kind of direction. So your row becomes, for example, 2, negative 3, the last one we just did, and sitting it next to the column you're trying to multiply it by, multiplying the corresponding elements, and then adding those two things together to get your final answer. Okay. Alright, let's have a look at another example. So we've got these two matrices. This is a 3 by 2 matrix. This is a 2 by 1 matrix. So it's going to be possible to do the multiplication, and the answer that we get is going to be 3 by 1. Okay. So let's write it out. We're going to have AB. It's going to be 1, 4, 7, negative 1, 2, 3 times B, which is 9, 12. And we know that the answer we're going to get is going to be other way around, 3 by 1. I'll leave some space so I can write them in. Okay, so every row in the first matrix must multiply every column in the second. So row times column, okay? So again, imagine that flipping around the row so that it becomes a column, 1, 4. Next to the existing column, 9, 12, we're multiplying and then we're adding, okay? So this is 1 times 9 plus 4 times 12. I'll write out the others and then we'll work out our final answer. Row times column. So middle row times only column goes in the middle of the only column of the answer. So 7 times 9 plus negative 1 times 12. And then the bottom row times the only column goes in the bottom of the only column of the answer. 2 times 9 plus 3 times 12. Okay, then we can work that out. 1 times 9 is 9, plus 4 12s are 48. 9 plus 48 is 57. 7 9s are 63, minus 12, so it's plus negative 12, so minus 12, so 63 minus 12 is 51. 2 times 9 is 18, plus 3 times 12, which is 36. So 36 plus 18 is 54. And there's our final answer. Now if we're going to do this on our CAS, we can type them in. So matrix, so I'll use the 3 by 3 template so I can specify that I want it to be 3 by 2. We're going to have 1, 4, 7, negative 1, 2 and 3, multiplying that by a 2 by 1 matrix, which is that template, 9, 12. So nothing more complicated than you simply enter the two matrices with a multiplication in between them, and your CAS will do the multiplication for you. But as I said, it's really important that you understand the process of multiplication or you'll really struggle with the rest of this topic. So it's really important that you practice. I want you to do these by hand in just practicing the skill. So why don't you have a go at pausing the video here and seeing if you can do this one before continuing to watch to see if you got it right. Okay, so hopefully you've had a go at it yourself, and let's have a little look. So A is a 1 by 4 matrix, B is a 4 by 2 matrix. So the multiplication is possible. The answer we get is going to be 1 by 2. Okay. Alright, so AB is going to be 8, negative 4, 2, negative 3, negative 1, 9, negative 3, 2, 9, negative 3, 2, negative 4, 1 and 7. Okay, and our answer is going to be 1 by 2. Just give myself a bit more room here. Alright, so we're only going to have two numbers. Okay, so the one on the left is going to come from doing only row times left column. It's going to give us the left answer in the only row. And then the answer on the right is going to come from doing only row times right column, and that'll end up on the right. Okay, so let's see what we've got here. Let's do the red one first. So row times column. So again, sort of imagining flipping around your column. So it becomes 8, -4, 2, -3, and it lines up next to the existing column. You multiply all those things together, and then you add them. Okay? Alright, so we're going to have, I'm just going to write it out, 8 times -1 plus -4 times 9 plus 2 times 2 plus -3 times 1. Might actually just move that onto a lower line so we can fit it in. I might actually get rid of this. Okay, let's move this over here. Okay, and then the green number, oh sorry, put it off there first. And the green number, so remember when in the matrices you don't have commas here, so they're not points, just make sure you leave a space. So the green number, again, thinking about flipping this around here, so thinking about having 8, -4, 2, -3, putting it next to the existing column, multiplying those pairs together, and then adding them together. Alright, so here we're going to have 8 times 6 plus -4 times -3 plus 2 times -4 plus, sorry, -3 times 7. Now you don't need to write out this full row of multiplications, I'm just writing it out so that when you look at it in the notes you can work out where the numbers have come from. I would probably, as I was doing that, perhaps at least just do those pairs of multiplications in my head. So I'd probably, in writing out, I'd probably in my head do what that 8 times -1 is -8, plus that's -4 times 9 is -36, plus 4 and plus -3, which is -3, and this plus -6 is -36. And then 8 6 8's 48, that's plus 12, and that's -8, and that's -21. So that's probably where I would go first. That'd be my first line of working, and then I'll do those additions. And if I need my CAS to help me along the way, I absolutely can do that. So what have we got here? So we've got, trying to think whether there's a combination here that might be helpful. Not necessarily. I might think about -8 plus 4 is -4, and then adding that onto 36 is -40. So all sorts of addition combinations there. So it's going to be -43 when I then take away the 3. 48 plus 12 is 60. Take away 8. Now again, you might do 48 minus 8. That's 40. Might be an easier thing to think about first. Okay, so 40 plus 12 is 52. And then 52 take away 21 is 31. Okay, again, your CAS can do that, but I want you to, it's really important that you understand the process of the multiplication, or you won't be able to follow some of the later ideas. Okay, example 3 here. A is a 2 by 2 matrix, B is a 3 by 2 matrix, and C is a 2 by 1 matrix. Determine which of the following products, product meaning a multiplication, when you find the product of two things, you multiply them together. Which of the following products are defined? State the order of the product if it is defined. Okay, so AB would mean having a 2 by 2 matrix times a 3 by 2 matrix, and so we've got an issue there, and so that is not defined. B times A would mean a 3 by 2 matrix times a 2 by 2 matrix. So this one is defined. With an order of, it will be 3 by 2. A times C, so A is the 2 by 2 matrix, C is 2 by 1, okay, so that is defined. Is defined with order 2 by 1. So there's the order there, the outside numbers. C by A is 2 by 1 times 2 by 2. Okay, so I've got a problem there. So this one's not defined. B times C. B is 3 by 2 and C is 2 by 1. So that one is defined. Is defined with order 3 by 1. So that's the order. And then CB, C is 2 by 1, B is 3 by 2. Okay, so we've got a problem there. So that one's not defined. And the reason it doesn't work, I mean, if you think about it, let's say if you've got let's take this one here, let's say you had a 2 by 1, okay, and you're multiplying that by a 3 by 2, okay. The way you do the multiplication, every row has to multiply every column. They're not the same length. So that's why you need the number of columns here to be the same as the number of rows here, so that when you do that, you've got the same number of elements in each of those things that you're trying to multiply together. So you'll find that if you try to do a multiplication where there's a dimension mismatch, then you just won't be able to do it. You won't simply have enough numbers to be able to do the multiplication to follow through with the process. We can easily do multiplication on the CAS. I've already shown you one of those. If you try to multiply two matrices where the product is undefined, you'll get that same error we've seen previously, dimension error. There's a problem with the dimensions in trying to multiply those two things together. Okay, the final thing I want to look at in this video is matrix powers. So squaring or cubing or raising, a matrix to the power of 10, for example. And if we think about it, because of the restrictions around the order of the matrices when we multiply them, only square matrices can be raised to a power. So if you think about, let's say if you had a 3 by 2 matrix and you were trying to square that, that would mean you would be trying to do a 3 by 2 times a 3 by 2, which doesn't work. Okay, so the only way you're going to be able to do it is if those two numbers are the same, and therefore the only way to work is if you have a square matrix. So a 2 by 2 matrix squared is fine because it's 2 by 2 times 2 by 2. And these are the same. If it was A by A times A by A, so any number, square matrix, that will always work. So we can only calculate powers for square matrices. That's the first thing. Okay. Then let's think about how we do that. So thinking about the powers are just multiplication. Squared just means that times that. And you simply just have to do that multiplication. So A squared literally means A times A. And so that is 1, 3, 0, negative 1. 1, 3, 0, negative 1. And you do the multiplication. So it's 2 by 2 times 2 by 2. So we'll get a 2 by 2 matrix. Okay. Left row times left column. 1 times 1 is 1, plus 3 times 0 is 0. I'm just going to try and take a few shortcuts in what I write. Top row times right column goes in the top right. 1 times 3 is 3, plus 3 times negative 1 is negative 3. Bottom row times left column. Okay. 0 times 1 is 0, plus negative 1 times 0 is 0. And then sorry, just finding another pen colour, and then bottom row times right, 0 times 3 is 0, plus negative 1 times negative 1 is 1. Okay, so we get 1, 0, 0, 1 when we square matrix A. Remember, that's called a unit or identity matrix. Unit matrix. When we have ones in the leading diagonal and zeros everywhere else. Okay, then if we want to do A cubed means A times A times A. But we want to think about how we can use what we've already done. So that's the same as having A squared times A, for example, or A times A squared. That's the same thing. So let's do it that way. Let's use A squared that we just worked out, which is that, and multiply it by A. Okay, so top row times left column, 1 times 1 is 1, plus 0 times 0 is 0. Top row times right column, 1 times 3 is 3, plus 0 times negative 1 is 0. Bottom row times left column, 0 times 1 is 0, plus 1 times 0, which is 0. And then finally, bottom row times right column is going to be 0 times 3, which is 0, plus 1 times negative 1, which is negative 1. Alright, when we do that, we get 1, 3, 0, negative 1. Now, interestingly, we'll talk about this later, this is not really the point I want to make here, but this is equal to A. So we found that A cubed is exactly A. And actually, one of the special features of this identity or unit matrix is that it essentially behaves like the number 1. When you multiply any matrix by a unit matrix, you just get itself. In the same way, 1 times any number just gives that number. The unit matrix times any matrix just gives that matrix. Okay, so in this case, we did the unit matrix times A, and we got A. Okay, last one here, we want to have a look at a to the power of 5. So again, yes, we could do a times a times a times a times a and be here forever. But let's think about the fact, well, that's a squared and that's a cubed. So let's use what we've already done. Let's think about this as being a squared times a cubed. And so a squared we already know is 1001, and a cubed we already know is 130 minus 1. And in fact, that's the exact same multiplication that we did up here. It's the same. Okay, and so straight away we know this is again going to give us 130 negative 1. But that might not always be the case. You might actually then need to do that multiplication. But think about how you can do the multiplication without necessarily needing to do 5 separate multiplications. So build it up. If you work at a squared first, then all you need to do is again multiply by a and you've got a cubed, and then you can multiply those together and you've got a to the power of 5, etc., etc. Okay, matrix powers with your CAS. So again, if you just put the matrix in, it has to be a square matrix. Let's just make something up. 2, 5, negative 1, 4, and then I can square that, and it will do that for me. So simply, I just press the squared button here over on the left next to number 4. You can also press the little hat button next to that to choose a different power. So if I want this to the power of 6, I can get my matrix that way. Okay, work today is a mixture of questions from 11D and 11E. In 11E, I'd like you to make sure you do question 1 by hand, and in question 3, you can use your CAS, so you get a combination of practice with both.